All right, let's jump right into this incredible story about a brand new weapon in the war against antibiotic-resistant superbugs. We're talking about bacteria that can build these nearly indestructible fortresses to protect themselves, but it looks like scientists may have just found the ultimate siege weapon to tear them down.
I mean, really think about that. That's the exact challenge scientists are up against. They're not just fighting a single bacterium. They're trying to figure out how to demolish the entire invisible, slimy city that these bacteria build to live in.
And that city has a name. It's called a biofilm. This is the superbug's greatest superpower. It's this collective shield, this gooey matrix that makes infections so incredibly tough to treat. Our best antibiotics just can't get through, and even our own immune cells get locked out. So who's the main bad guy in our story today? It's a bacterium called Pseudomonas aeruginosa, and this thing is a real piece of work. It's a huge cause of hospital infections, loves to grow on things like catheters and medical implants, and it is an absolute master at building these fortresses and resisting our most powerful drugs.
So how in the world do you defeat a fortress like that? Well, the researchers here did something really clever. They didn't just go looking for a new, stronger antibiotic. Nope. They turned to this really unlikely partnership between a natural compound from a plant and a whole new class of designer liquids.
The game plan was to create this special kind of liquid, something scientists call a SDGs. You can just think of it as a custom-made cocktail, specifically designed to dissolve the bacteria's defenses. The recipe is pretty cool. They start with saponin, which is a natural, almost soap-like extract from a tree. They combine that with a simple acid, add just a little bit of water, and warm it up. And boom, you get an entirely new liquid with totally unique properties.
So they put their new creation to the test. They whipped up 5 different versions, each with a different acid, to see which one worked best. Now that number on the right, the MIC, just tells you how potent it is. All you need to know is, the lower the number, the better. And wow, it's not even close, is it? The one with malic acid, which they call SMA, just absolutely blows the others out of the water. It is way, way more effective. Okay, so they had a clear winner. But you know how scientists are. Good is never good enough. They knew the exact ratio of the ingredients was absolutely critical. They had to find the perfect, most powerful recipe for their new biofilm-busting weapon.
So how do you find that perfect sweet spot? Well, they used this super sophisticated technique, but forget the fancy name. Just think of it like this. They basically created a 3D treasure map. And instead of looking for gold, they were mapping out every possible recipe to find the one single point of maximum power.
And here it is. This is their actual treasure map. You see the flat sides at the bottom? Those represent the amount of each ingredient, saponin, malic acid, water. The computer then builds this hill, showing how effective every single combination is. And that highest peak you see right there? Yep, that's the treasure. That's the single most powerful, perfectly balanced formula.
And this is what that map gave them. The X that marks the spot. The perfect recipe down to the thousandth of a part. A hyper-specific, totally optimized combination. So now, with this precise formula in hand, it was finally time to put their perfected weapon to the ultimate test.
All right, this is the moment of truth. They've got the perfect formula on paper, but can it actually tear down that biofilm fortress? The scientists needed to see it for themselves. They needed visual proof.
And oh my gosh, the evidence is it's stunning. On the left, that's what the biofilm looks like under a powerful microscope. It's a dense, thriving city of bacteria. And on the right, that's after they treated it with their optimized liquid. That city is it's in ruins. The biofilm is almost completely wiped out.
So how does it work so well? Well, it's a multi-pronged attack. First, it basically punches holes right through the bacteria's outer defenses. And at the same time, it makes the bacteria themselves less sticky. It's kind of like it strips away their Velcro so they can't even clump together to build their fortress in the first place.
Now, destroying a biofilm in a lab dish is fantastic. That's a huge step. But the real test, the one that really matters, is can it work inside a living creature? And even more importantly, can it do that without causing any harm?
To find out, the researchers turned to a tiny but very useful creature, the zebrafish. Now you might be thinking, a fish? But as the paper points out, these little guys share over 80% of their genes with us humans. That makes them an amazing model for testing out new treatments for infections.
And the results from the fish study? Well, they speak for themselves. That tall bar on the left, that's the level of bacteria in an infected fish that didn't get any treatment.
Now, look at the bar right next to it. After just one treatment with this SMA liquid, the bacterial count just plummeted. It dropped to less than a fifth of the original level. That's a massive success.
But remember, being effective is only half the battle. Was it safe? The researchers did a checkup, looking at key markers for toxicity in the brain and the liver. And as you can see, the levels in the treated fish were completely normal. There was no negative impact at all.
And if you want the microscopic proof, here it is. It's undeniable. On the left, that's the liver tissue from a healthy, untreated fish. On the right, the liver from a fish that got the treatment. I mean, they look practically identical. This confirms that the compound did its job and left this vital organ completely healthy and intact.
So when you put this all together, it suggests a whole new way of fighting infections. What if, instead of just searching for new drugs out in nature, we could actually engineer and design entirely new liquids, perfectly optimized to dismantle a bacteria's defenses? It's a fundamental shift in strategy, and it could give us a powerful and much-needed new edge in the endless war against superbugs.